Hello everyone. Sorry, I'm 1 minute late. Non-farm, Abdullah, Santiago, Loyal Moses, and yes, thank you for being here before me. How are you guys doing? Bonjour everyone. Bonjour, bonsoir. Oh, you guys are all learning French? I'm wondering if I need to do the stream in French then. Then you guys can learn faster. First, Loyal Moses. Okay, so let me check. Is it the camera is a little bit tilted? I put it on a new spool. Is that better now? Okay. Can you guys hear me well? Can you confirm that there's no? Because last time we had some connection issue. Really sorry for that again. I have my anti-stress snake printed in Polyflex. Very, very, very flexible. Well, although I printed it with quite a high infill, so just enough to squish it when you're stressed. Audio and videos are great. Thank you, Loyal, for confirming. So yeah, if you guys like this snake, you can download it on Thingiverse or Thanks 3D. I like to design toys, and I designed this small snake on Blender. I like Blender, not the best user interface, but if you are a little like computer nerd like me, I think Blender is a nice 3D modeling software. So you can make this kind of shape pretty easily, and then you have the eyes and then the tongue, and then you end up with a nice design, or look like a nice design, but pretty easy to model actually. We have Brian Farmer that just joined as well. 3D Medic Vines. We have Maker Millwright. A lot of names that I've seen before. I'm really happy that you guys are joining again. Oh, Josia, I think we missed you in the last stream. I might have to miss this because I'm in a car and someone is on the phone. Yeah, no. Safety first. Safety first. If you are in the car, if you're driving, don't follow the stream at the same time, because we are going to talk about very interesting stuff. So you might be a little bit disturbed by wanting to listen to the stream instead of focusing on the road. Davey B, nice snake. Yeah. I think I printed a couple of them. I printed a very big one, I think a 400 scale, and I printed 3 of them, and I gave it to my wife's school. My wife is a teacher, and then I gave to the school so that the kids can play around with the snakes. I mean, it's pretty nice in flexible material. Abdullah had another look at Eason TDS after the last stream. Although they list some print setting, they mention in fine print that tests are based on injection molding spline tests. Yeah. Okay, so that could explain why the numbers were higher than 3D printed one. Maybe because the specimen were injection molded. Hello, my dudes. Good to see you again. Yeah, it's nice to see. It's nice to see that we have more and more people here talking about 3D printing. I really love it. Explain 3D printing to me like I'm 5. Oh, I saw that tweet, Loyo. I checked all the different answers. I think it's an interesting question. I actually did. If you check on YouTube, I did a video where. But I think we cannot see it in the video, but I did a video where I presented my toy project. Before I joined Polymaker, I was working on creating a brand of digital toys, which and kids could print them at home. And then I presented the project to a kid. But I think during the video, we don't really see, we don't really hear what I'm saying to the kid. But you have some shot where I'm trying to explain to the daughter of our CEO, who was I think 6 or 7 at that time, and I was trying to explain how I build all of these models on Blender. You can check the video. It's called NT Toys, like Polymaker NT Toys or something like this. It's pretty nice. Great. What is 3D printing? Okay, actually, 3D printing, a lot. Some of the people think that is a bad name. Additive manufacturing should be the one that everyone should be using. In a way that 3D printing means you're really creating something in 3D based on. I don't remember their main argument, but I think the main argument was 3D printing was misleading in a way that you wouldn't understand properly how the technology, the actual technology work, which is not printing like 2D printing. But anyway, that's not the subject of today. So today we are going to talk, and I have my notes. I usually forget them, but we are going to talk about multi-material. So last time we talked about multicolor printing. So printing with many different color, but with exactly the same material. Whether you're printing with PLA and then you print with all the different PLA color. But now we are more going to talk about multi-material. So trying to have one print with different type of material, and I think that that's going to reduce a lot the amount or the type of technology we have. Because last time, if I remember well, all the technology we had for multicolor printing, I think there were 4 types of technology, and maybe you will have to help me to remember them. But I think the first one was the same nozzle, and so one nozzle, one extruder, one nozzle, one extruder, and then you just have a machine before that helped to splice the different filaments, such as the pallet from Mosaic Manufacturing. So that was one technology to allow multicolor printing. The other one, so one nozzle and multiple entry. The other one was the tool changer, where you have many different nozzle, and then you can select the one you want. You have the whether it's the IDEX one, whether it's 2 nozzle on the same print head, etc. So that was the second one. So multiple nozzle, multiple extruder. Then we had the color mixing. So you have a kind of diamond nozzle where you have a CMYK, and then there is a kind of mixing that is going on, and then you extrude more or less some of the material in order to have the desired color. So let's call it a diamond nozzle idea. So that was another idea of printing multicolor. And then the last one was, the last one was you print with a special filament, and then you use inkjet on top of it, and then the filament will absorb the color. So that was the technology from XYZ printing from Taiwan. So let's call it inkjet. And I think that was the 4, if I remember well, that was the 4 main technology when it comes to multicolor. Let me know if I missed any. I think it was only 4. Make a meal right, Polymaker. You need to try my Erector Say toys I designed. Which one? Maybe you need to send it to me. Send it to me. What's that thing wearing an orange cape? What that thing wearing an orange cape? You mean that thing? Oh, it's not a cape. It's a bust. So actually, when I joined Polymaker, I printed a full size Naruto. Do you know Naruto, the Japanese manga? And so I printed it with flex. This is the feet. I printed it with flex. I printed it with polysmooth. I think you can remove this, but I think it's been there for a long time, so might be hard to remove. And then I printed the hand also with polysmooth, and then I printed the legs. I don't have the full one here, but it's like Naruto full size, and then he's doing like this. I don't know if you guys know Naruto, but it's one of my favorite manga anime. When I discovered 3D printing, when I arrived, then that's the first thing I printed. So I didn't model it. I took a model and then I put it on Blender and I remodeled a little bit to what I liked, and then I printed this. But it's supposed to be a cabin behind, a cape. Looks like something made with Polysmooth. Yeah, so this is Polysmooth, the black one, and the part on the side are another material. It's Polylite PLA, the orange one. And then you have this part. So I broke it down. I cut the model to print it easier. And then so that's another way to do multi-material. You just cut the model into different parts and then you just print them separately. Builder marks. I got filament from. Oh, you got the filament today. Great, builder's mark. And I didn't forget. I will save some of the sparkle. Actually, if you go on YouTube and then you type Polymaker and then you just rank by date. Some of the latest video was a Japanese guy that made some video about the sparkle dark blue and sparkle dark green, and the print are amazing. It's like a skull, but it's just so nice. I can understand why Loyal really like this material. Well, it's polymer extruder while being driven by CNC subsystem. I got a bunch of HIPS plastic recently. I understand it works well as a support, dissolve in limony. Yeah. HIPS, usually HIPS is quite old. They used to use that because we started by using ABS, and then HIPS was working well with ABS. So when we started to need it more specific support material for ABS, then we started to use HIPS. But I think there is better solution. Okay, so yeah, so I guess nobody else had some other technology. So only this one nozzle, and you just splice the filament in many different way, or you extrude different filament in the same nozzle. Then you have the second technology, which is different nozzles. And then you have the diamond one, CMYK, and then you have the inkjet one. So when it comes to multi-material, the big downside is that you end up with almost none of these technology. So one nozzle, multiple extruder, I think very, very hard, because if you have two different material, meaning they have most likely two different printing temperature, two different type of setting. So you would need, in order to use the first technology, you would need either to have a very high-end nozzle that would be able to change the temperature very rapidly. The second one, and also the type of nozzle, like if you're printing with PLA, or let's say, if you're printing with non-abrasive and an abrasive one, then even the nozzle theoretically should not be the same, or except if you go into I've seen the diamond nozzle, which solved a little bit the heat break nozzle, but I haven't tried it myself. The heat conductivity issue, but yeah, there's so much different into the setup of printing different material that having only one nozzle multiple extruder, I think, is a technology that doesn't have much future. I guess the second one is the multi-nozzle, multi-extruder. I think that's the only one from the list that could work. The diamond nozzle definitely doesn't work because we're not talking about mixing material. Although you have continuous fiber printing, right, where they are using a matrix polymer, let's say nylon, a pure nylon, and then you are using a continuous carbon fiber, and then they mix in the nozzle, and then you just lay that on your model. So, but it's very limiting. It's only to reinforce a certain polymer, and then the inkjet is completely different. So at the end of the day, for multi-material, currently we only have one solution, which is different print head, tool changer, or the IDEX printer like the Race 3D E2, or two nozzle on the same print head, like the Race 3D Pro 2, for example, or the FlashForge, or the Ultimaker. So now the question is, what do you guys think is the best sub? Like, what is the best idea of implementing multi-print head? Well, maybe my first question would be, do you think that's the only solution? The only solution of printing multi-material in FDM printing is just having many different extruder plus the nozzle. So in my opinion, I think yes. I don't think there is any other solution compared to multicolor. Multicolor, you have a whole bunch of technology, while you have 4 that we mentioned there. But for multi-material, looks like we only have 1. And however, I still think multi-material is really important, or like, even if there's only 1 technology, is really something we need to continue innovating. Why? The main reason is, think about all the different 3D printing technology. I don't know, SLS, SLA, DLP, all the other technology. How many of them can do multi-material? SLA, no. I think it could be very hard. You would need to have in deep in one resin, and then go to the other resin, and then go to the other resin. But I think could be, but I don't think it would be very easy, because you're going to mix the resin between within each other. So you would need to dip into the resin, cure the resin, and then clean the part, then go in the other resin, cure the resin, clean the part, etc., etc. SLS, I don't think so, because you are basically sintering powder. So you would need to have your mix of powder that is already different material. And yeah, on top of my head, I don't think it's possible. DLP, similar issue as SLA. What else? SLM, melting, selective laser melting for metal powder, same. You have the same issue. So at the end of the day, except if you guys come up with a different technology that can do that, I think FDM, or material extrusion 3D printing, is one of the only one, or the only one, that can do multi-material. So when we talk about multi-material, what are the interesting part of that technology? The first one is support material. The good thing is you can use a different material for support. You can see, for example, this is Polymax PLA with poly support. There's 2 reasons. The first one is you can use a support material that is easier to remove, that doesn't stick too much to the main material, so that is easier to remove, or a material that sticks very well but can dissolve. So this is what? This is most likely Polylight PLA. It's a T-Rex, but printed upside down. That's actually a good tip if you guys are looking to use dissolvable material. Don't print this way. Like, just flip it. It would give you much higher quality. But what I was about to say, yeah, you can dissolve the material. So the good thing is you can print a different material for the support. And one more thing, you can print a cheaper one. If you're printing, for example, we have a lot of people that are printing with PTG, and oh no, but that's different because the price point is similar. But just a quick note, we have some people printing with PTG, and in order to support PTG, they use PLA, which I thought it was funny, but I think it's very smart, because PTG and PLA doesn't stick as well as PTG to PTG. So I think it's smart to use PLA as a breakaway material. But anyway, like for example, if you're using polycast, that is a more advanced material, you may not want to waste all of this support with your polycast material. So in order to be more cost effective, you could print with polycast and then print with PLA all the support, for example. Or you could also have a support material that is very expensive. Let's say our the Stratasys SR30. It's a very good support material. It can support high temperature material. However, it's very expensive. So what you could do is to print all the support with one material and only the interface with your expensive support, and then just dissolve that. And then when it dissolves, the interface will dissolve, and then all the chunk the big chunk of support below will just come off. So that's all. That's one way to use the multi-material printing for your support. The other way is to integrate different features of the material. For example, unfortunately, I couldn't find it, but 3 or 4 years ago, I printed a small puppet. And how I did that is I printed like the head, the bust, and all the limb with Polylite PLA. And then inside, I printed a skeleton with Polyflex. So it was like just like some small cylinder that I put inside with Polyflex. And then there is some gap in the puppet model. And then when I took it off the bed, then I could play around, because it's all the parts are hard parts, PLA, but all the connection, like the skeleton inside, is Polyflex. So you can imagine this. So this is like the blood vessel that goes in your what? Maybe your lung. I don't know. I don't remember which one is this one. But this is Polyflex. We printed this with Polyflex because we printed it with PLA and we kept breaking it. So I printed it with Polyflex. Then we don't break anymore. But yeah, the idea is you have this small thing inside the print, and then to make the print much more resistant, and then to have this articulation. So that's the two way I would use multi-material printing. One for the support, and one for using different feature of the material, like flexible or hard. Is there some other example? You could print. You could have, for example, the infill that is printed with. Oh, I guess still there. Yes, yeah, should be there. So the infill is printed with a cheaper material, and then the outside is printed with a high quality material. So you could print, for example, this Polysmooth part. Polysmooth is higher, so the price is around. I think it's 2 times PLA, if I remember well, $39.99 for Polysmooth, and I think, but for 750 grams, and then $21.99 for the Polylite PLA. And so what you could do is, like this shoe, you could print like the inside with PLA, or let's say a very, very cheap one, or you could even print with Polytera PLA inside, which is our most cost-effective material, and then the outer shell you printed with Polysmooth, and then you end up saving a lot of Polysmooth, right? And you can still smooth the material, because at the end of the day, you need Polysmooth only for the outer shell, right? You don't need it for the inside. So that's another way to use like different feature or different material. One is cheap. One has a very specific smoothing properties. Or let's say you want a very smooth part, but you want it to be very solid, or like a very high mechanical property. I haven't tried it yet, but you could print PA12CF. Well, maybe not, because PA12CF already have a pretty good finish. But let's say, let's say PA12CF. But you put PA12CF inside, like a very smart infill, in order to have good mechanical property, and maybe even a few shell. And then you print maybe 2 outer shell out of Polysmooth. So you end up with a very smooth part, like this one, but also very strong. Or well, you have to consider heat resistant, etc. Maybe not the best idea, but you get what I mean. You can multi-material can allow a lot. And when people ask, what's your thinking on which of the 3D printing technology or is there a 3D printing technology that will take over? Like over SLS, SLA, or even FDM. I don't think so, because they all have very interesting pros, and also they all have cons. But when I ask about the pros and cons, I think one of the big pros of FDM is multi-material. FDM, you have access to like a lot of different materials, and you can combine them together. So yeah, that's some ideas around multi-material. Let me check. I missed some of them. Blah blah blah. I got that one. Running builder marks, running some Polylite silk silver right now for a friend project. Nice. So for silk silver, a small announcement. We made a change. The silk silver that was on the plastic spool is now called the silk chrome on the cardboard spool. And the silk silver on the cardboard spool is a new version. So it's lighter. So with the plastic spool, the silk series was in beta testing. And we received a lot of feedback that the silk silver was too dark. So what we did is when we switched to the carbon spool, so when we finished the beta testing, we decided to redo the silk silver with a lighter one. So it looks more like silver. And then we kept the silk silver that we had during the beta testing, but we called it the silk chrome. So just something good to know. Ninja moves. It's okay, Nick. We are all nerds here. Yeah, all 3D printing nerds. Santiago, okay. I printed a 1x1 body size sculpt recently with Polytera. Worked out well. Oh, really? Oh, that's nice. Like a 1-1, because Naruto is pretty small, right? Maybe 160, like 1 meter 60 centimeters. I don't know how many feet, but he's not very tall. But if it's a 1-1 body size like me, like 2 meter, then pretty nice. What would you recommend if my filament won't stick to the print bed? Official preach. Multiple things to look at. The first one is the compatibility between your filament and the print bed. Yeah, let's say I assume you're using a PLA if you don't mention. So let's say you're using a regular PLA. So I can suggest PEI, Buildtech, even glass with glue. I think all of them should work. So most likely if you're using PLA, it's not a bad problem. Maybe make sure that the bed is leveled. So leveled means when you're printing the first layer, if you rub your finger on it, then it won't stick, which means the bed is pretty well leveled, and then you don't have some part that are squished too much and some part that are too further away. And then a quick tip is you can increase the build plate temperature to 60 degrees. If you have it at 40, 45, or 50, just go up to 60 degrees. And then you can lower the print speed to 30 millimeters per second and print a little bit higher. So to summarize, level the bed, print at 220 for the first layer, like the first few layers. Make sure the fan is not on. The print bed at 60 degrees and the printed speed at 30 millimeters per second. Do all of this and you should have solved your problem. If not, just contact me via the social media, and then you just take a picture, just send it to me. We'll figure it out. I will check that out. Check the Japanese video. Pretty nice. Amish Gnome, hey, how is it going? I'm currently running Polytherapy Black so far. Great stuff. Thank you very much, and thank you for coming to the stream again. So. If you have Polytera PLA, normally you can take some picture, but you will have a very nice matte surface. I don't know which layer height you are using, but you should be able, if it's well calibrated, you should be able to have a surface finish that is almost seamless. Do I have some example here? I don't have. I have the PLA, the Polytera PLA. And then you are going to have a similar result, but a more matte result, because this is PLA plus. Make a Milrad. Well, I see smart printers with isometric camera that do comparative math. Then for giving the machine to be able to prevent layer shift or fail to do jump. What a dissolvable dual head will be served. Maker's Mirror. I'm not sure. I'm not sure I read it well, but yeah, there is more and more. There is more and more software that can analyze the, let's say, the health of your print. So you have, for example, you have a spaghetti. Spaghetti Detective. The Spaghetti Detective, I think it's called. It's a company that watch your print, and then they can detect if there is a spaghetti, and then stop the print. So this is nice because it avoid the mess, and then it saves some materials. But I think it only pause the print, and then you need to check. But most likely, if they detect the spaghetti, then most likely the print is ruined already. It's failed. There is another one. It's called 3DQ. The company is called 3DQ. I don't remember the name of their product, but they have an AI that can analyze how healthy is the print, and I think maybe they can alert you a little bit before it happened, or not before it happened, but maybe, yeah, I don't know how they do that. But yes, there is a couple of software out there that can help with that. And actually, Polymaker has invested in a startup company called Helio Additive. You may have seen the news on what? On All 3DP, I think, or maybe Fabaloo, or one of the printing news. And this company is also for us. I think they are working on something really, really good to improve 3D printing, to improve the 3D printing process. We have David B. I could imagine laying down discrete color of powder CMYK in stages for SLS, blow away each layer before adding the next. Yeah. So David B, that would be for multicolor. That would be one idea to implement that in SLS. Although SLS is powder based, so I think the inkjet idea would work well. And it won't damage the glass. I'd like to try that polycast. I need to get a dual extruder first, though. Polycast, you don't need a dual extruder. Polycast is a casting material, so it helps you. Yeah, we have so many materials that I have difficulties to keep at least an example of all of them around me. But you just print something. Let's say this is printed in polycast, and then you smooth it with alcohol, and then you build a ceramic shell around it. So you dip it in ceramic, and then you dip it in a slurry, and then mix with sand, and then slurry sand, and then you try to build that ceramic shell. Then while you sinter the shell, you are going to burn out the polycast, and then you end up with an empty shell, and then you can pour the molten metal inside in order to have this exact model, but in metal. So that's what the polycast for. But the polycast can support itself. It has pretty good property because it doesn't need to be very strong. So we compromised a little bit more for the support removal. So it's very easy to remove the support. Abdullah, ligament made of TPU. Yeah, for the puppet, that was the idea. The idea was to have it's like you have this snake, and then you have an armor of like some PLA stuff, so you can still move the snake because like the backbone of the snake is flexible, and then you have some like a helmet, like some protection around it that is made out of hard material. No, we kept breaking it, so we just made a new product so we would stop breaking their toys. What? Yeah, I'm so late in the chat that I don't remember the topic, but the idea of the school is why I printed all the toys in TPU, because TPU is unbreakable, right? So I printed everything in TPU so that like even if you have some small some small thing like this, or even let's say this guy here. So if you print the rear mirror on the side mirror, you see that one? If you give that to kid, definitely in less than 2 hours, this thing is broken. But if you print this in flexible, then it's it's kid proof. Wow. Oh yeah, that's the gasoline. So yeah, it would be kid proof. Everything that is made of TPU is kid proof. So that was the idea. I have a very robust mechanic. Blah, blah, blah. Just keep going. You are just unbelievable. Nerds. Yeah, we're all nerds. I mean, yeah, I mean 3D printing. You know what is great with 3D printing is that it's very new. There is a very few research paper on 3D printing. I mean, there's a lot, right? But just compare it with other technology. So it's the kind of area there is still so much to discover. And if you like discovering, if you like learning, then that's one of the best technology out there. Amish Gnome, running 0.2 layer height, got some slight line issue, but it's from me trying to switch from Cura to Prusa on an Anycubic Viper. Okay. Yeah, actually, it's very interesting that you're saying that, because depending on the slicer you're using, the result will be different for many different reasons. But there is one reason, well, at least there is one time where the slicer change made a huge difference. There is a user that was printing something like this. It was like a door. It was a door, but on the door he wanted to replicate the wood texture. So you had a lot of relief on the side, like a lot of fine detail. And then he was printing with our Polytera PLA, and he had a big issue is that you had a lot of lines, like it was not very good quality. And then so he contacted our customer service, and then we couldn't think about what was going on. And then I remembered a video from I think it was from Stefan, and then he was talking about a similar issue that he had. And then I also remember because I worked at Ultimaker for a couple of months as part of a partnership between Ultimaker and Polymaker, and I still remember the discussion around the algorithm to slice the material, to slice the model. And then if you have too many triangles on one side when it starts to slice, because when it slices, it basically creates a plan, and then it checks all the triangles that intersect with that plan. And if I remember well, if you have too many of them, he's going to take some shortcut between them. And the problem is, if he doesn't take the same shortcut from one layer to the other layer, then on one layer he's going to take a shortcut like this, on the other one he's going to take a shortcut like this. So you end up with a lot of layer lines that has like a lot of artifacts. And then I asked him, so I think he was on Cura. I asked him to switch, or he was on Prusa, and yeah, I don't remember. I think he was on Cura, and I asked him to switch to Prusa, because I think the Prusa, I mean, Cura can also do it, but I think Prusa by default has somehow has a more finite way of dealing with this. Sorry, I don't have the vocabulary yet. I don't remember exactly how the setting is called. But he just switched to Prusa, and then the print came out perfectly. So, and then I asked him to go back to Cura and then change. I think there is a setting, but I don't remember which one. I need to check. There is a setting that you can change, and then he can deal with this. And he changed that setting, and it was better, but I remember it was not as good. But I think it was better. So definitely, depending on the slicer you're using, you will have different results. I mean, for 99% of the model, it should be similar, but for particular case, one slicer will handle it differently than another slicer. Another one is how to deal with the oozing. How to deal with the stringing. I think Cura, I think now Prusa and Idea Maker, I think they have this. Idea Maker, I'm not sure, but Cura has, by default, has a specific wiping movement from one island to the other island, which make Cura much better when you're printing a print with a lot of island. So this one has like maximum 5 islands. Well, I just counted how many fingers there is, so I confirm there is 5 fingers. So there is 5 islands, and then Cura will provide better result in terms of stringing between the fingers. But I mean, it's very hard to keep up with all the different slicer update. So most likely right now they all have very interesting features, and I'm very, very excited for Simplify 3D. I mean, I started with Simplify 3D. I know there is some controversial discussion around how they treated their customer, but still, I think they were very ahead of time, and I hope the V5 will also be ahead of the time of today. I don't know how. I think Idea Maker, Cura, Prusa Slicer. I don't have any other. I think these 3 are already, I mean, amazing for being free. So I'm not sure how Simplify 3D is going to have the same gap they had when they released the first Simplify 3D. Make a mirror right. Polymaker, what layer height do you like with Polytera white for the super smooth finish? I'm in the layer line club, which means I love when I see layer lines, because if you can see layer lines, and if the print is good quality, it means you really nail down your setting. Like if you have this very consistent layer, even if it's a thick layer, but if it's very, very consistent, very smooth, then for me it looks much better than like printing at 0.006, like the Ultimaker high quality setting, and then you end up with something you don't see the layer line. But I don't know, I'm more in the team of like layer line team. That's why I usually use 0.25, 0.2, 0.25, sometimes 0.3, depending on the print, because I also like when my print goes fast. When I print something, I think this one was 0.25 most likely. Yeah, or even 0.3. I can see with the top shelf, and you see you can see the layers. Maybe not on camera, but you can see the layers. But it still look nice. So that's up to you. That's up to what you like. Nick, I was talking about future printers. Oh, future. Okay, so you mean when all of these intelligent software would be integrated to the printer, so that the printer can react dynamically depending on the print? Yeah, that would be amazing. If the printer kind of like there is a bunch of sensor and then it can react. Oh, you know what? There's already one printer that was doing this like 5 years ago. It's the what? It's the robot. Oh, I forgot. iRobot. No, not iRobot. There is one printer that was released. It's like a blue. It's like a flat printer like this with a curved front, and it's blue and black, and it used proprietary spool on the side, like a small one. Oh, what's the name already? I think there is a robot inside. Robot. Oh, I don't remember. Like a dark blue, I think. Oh, what's the name again? and basically they had a lot of sensor inside their printer, and then if there's a jam, they could run like a unjam process where it would heat up a lot, build up the pressure, and then just expulse all the pressure, and then that would solve the clogging issue. And then they have a lot of system. It was a very smart one. I mean, once you close the front, you couldn't access anymore, and then you would do all of this stuff. Oh, I wish I remember the name so that you can check out. I think it was a UK based 3D printer manufacturer. It was pretty big at that time. Oh, Robux. I think it was. Is that Robux? Let me check. Thank you, Abdullah. Is that Robux? Let me check. Robux 3D printer. Oh, Cell Robux. Yeah, from Cell. Yeah, that's the one. So CEL. Cell Robux. So this one for me was you can call it a smart printer. I think it had like many different stuff inside. I think it was ahead of the time. I think they took an interesting route. I don't have any update on this company yet, but I hope they will continue that idea. I think there is still some work, but I think that was one of the first printer that we could call it smart in a way that it kind of reacted depending on what was happening. I haven't seen it on industrial machines. Yes, indeed. Well, actually, industrial machine means, there's two ways to go. You either go the way where you make something like very, very complicated and smart. You get what I mean? Like you have a bunch of sensor, you have additional mechanical stuff, and then it makes the printer smarter, but the reliability, well, it could be very, very reliable, but maybe the durability, or you have all of these pieces. Like, just check a 2D a professional 2D printer. You see all the stuff inside. Like, it's very, very smart. So that's one way. And then you need to have some kind of process to explain the user. You have to open here, unjam the paper, and then turn this switch there, and then close there and close here. So you could go this way, or you could go another way where you make something that doesn't have all of these sensor, etc., but it's very robust, and it's very reliable. But if it's broken, then you always have to tinker a little bit with it. I don't know how to explain exactly, but you have these two ways of going. I like both, but I think when you go on the industrial level, then you need a machine that is easy to maintain and reliable. So if you go the route of being very smart, of having all of this kind of sensor, it's great if it's super reliable, but if it's also easy to maintain. I guess most of you have upgraded your 3D printer. If you receive an Ender 3 V1 or even V2, you most likely change to an all metal hot end. You most likely change the extruder gear. You may have put a BL touch or whatever things. But what allows you to do that is because the design is super, super simple. Once you get to know the 3D printer, there is all the basics hardware of the 3D printer, and then you can tweak it very easily. You can maintain the machine very easily. But the Robux was very hard. If you have a problem with the Robux that couldn't be solved by the machine itself, then it's finished. You have to send it back to Cell. You cannot tinker too much about this kind of machine. So I guess that's what I mean. Where was I? I was talking about, okay, good to know. I was thinking I had to print the polycast with another support material. No, you can also self-support it. What I was saying is polycast is a very specific material, so the price point is higher than, let's say, regular PLA. So if you want to save some material, you could replace the support material with another one, so that you don't have to use polycast as the support material. That was the idea of using two different material. Amish Gnome, thanks for the info. Make a mirror. I know, but no one is doing it. But in the future, and it will be 3 heads, and it will be belt. Oh, belt printing. Yeah, that's. What do you guys think about this infinite Z printing? You know, the belt driven printer. So my thinking on this one, well, first, I think it's a brilliant idea. I think it's very innovative. I think it's you know, it takes the idea of 3D printing to a different route. Belt printing, XY, Cartesian, and then the Delta, and then you have the Polar printer, and then you have the Scara printer. So you have one new kind of printer. By the way, do you guys know any other kind of printer? So from what I know, you have the Cartesian one, so like the XY, and then you can have the H design. You can have the Core XY design, which is similar. You can have the regular XY, but anyway, I put all of this into the Cartesian design. And then the Delta is also using Cartesian coordinate, but in a Delta way. So Delta, I like it because you don't have any ghosting or ringing issue, because all the acceleration and jerk are on the Z axis. You don't have any on the XY axis. I printed, if you go on our Facebook group, maybe 5 or 6 years ago, I printed one big model in a Delta printer, in one of the best Delta printer, and the same one in one of the best Cartesian printer. So it was the Ultimaker, and it was the Mass Portal Delta printer, and you could see the difference. You could see, like, you could see how it was so high quality that you could see how the slicer sliced the curve, like it was an organic shape. So how it was slicing the curve, and you could see how the printer was managing this curve. And so yeah, you can check. I will try to bring back the picture and then posting it again. But that was a huge difference between the Delta printer and the Cartesian printer. But anyway, so Cartesian, Delta, then there's the Polar printer that is using the polar coordinate. You have the Scara printer that is also using the Cartesian coordinate, but moving with Scara system, so the ARM system. And then you have the belt printer, which I would put in a different category. So you have 5 types of printers. If you guys know any other, please let me know. I want to discover more type of 3D printers. What do we have next? David B, more moving parts is always bad generally. Yeah, that's what I wanted to. That's what I wanted to say. Like, the smarter you go, and the more stuff is going to be, and the more stuff there's going to be, and the more difficult it's going to be to make it reliable. So that's always the compromise between making something smarter and but still functional and reliable. I mean, if you look at our smartphone, right? We went a long way to have something so smart and so compact and so reliable and durable. So 3D printer will also go, I believe, the similar way. I will end up like egg breaking machine. Amish Nom, answering to Builder's Mark. Yes, I agree. That's why I want smart machines and dumb machines. It's like machining, manual machining versus CNC machining. Yeah, correct. I have none of those things. Freehand 3D printer, Abdullah. Yeah, actually, you're right. We have one more, the sixth one, which is the 3D pen. So 3D pen is basically you know, like Abdullah say, right? Freehand 3D printing. So you do have six type of 3D printer, or like material extrusion 3D printing. David B, 3D pen. Yeah. I missed that one. Santiago, there are cylindrical coordinate printers too. I think the bed spin. Yeah, Santiago, that's I think that's the polar printer. So you have the bed that is, so they are using polar coordinate, which is theta and the radius. So the angle and the radius. So the angle is controlled by the bed, and then the radius is controlled by your arm, and then they are printing like this. So if that's what you mean, then yeah, I think that's the polar printer. I love 3D print. I have a favorite brand for 3D pen. Is that there's many brands for 3D pen, right? Is that the 3D doodle, or 3D pen have the most advanced control system out there? Oh, really? What kind of? Oh, okay. I just got it. Yeah, definitely. Not the most accurate, but the most advanced. So okay, I think I caught up with the chat now. So like we said last time, we had towards the end of the stream, I said that from now on I will give away one spool of your choice. So I'm not going to send a random spool, but that's going to be up to you. So you can tell me whatever spool you want from our portfolio. So 1 kg or less. So you can have even PA12 CF if you want, PA6 CF if you want to try, Polycast, Polysmooth, PLA CF, whatever 30 plus materials that we have. So in order to do that, what I have done is I still don't have a specific tool to just randomly pick from the chat, but I have an Excel file where I already put like, that's very the old way. That's the nerd way of making a giveaway. And then I put all the names that usually come to the stream. So I already have most of you. And then I'm adding the one that I didn't have. So we have 16 different people. Yeah, old school. And then I'm just going to use a random function. Okay, so I think I have everyone. Let me check. I have 16 and we are still 16. But let me check if it's the right one. I wish I have the same thing as Loyal. I think Loyal just need people to bang enter in the chat, and then you just have to click someone, and then you just have to click something, and then he has the winner. I don't have that system yet. Okay, so I'm now going to do the giveaway. So it's gonna be, well, I hope it's not Loyal Moses, because he already have so many spool. So we're gonna draw number 6. So who is number 6? Abdullah. So Abdullah, are you still here? Nawaz Abdullah. Yeah, Loyal Moses, bang enter. I need to have do you guys know, do I need to move to Twitch in order to have this system where people can just do something on the chat, or is there some tool for YouTube? Because at some point I'm not gonna have all the name in the Excel, but yeah, Abdullah. Okay, great. So you were selected with the most old school giveaway tool, which is random from Excel. So congratulations for your free spool. So you can contact me either at this email address. Let me just type it in, nicolas.tugotu@polymaker.com. You can also send me on Twitter, whatever social media. It's gonna go straight to me, or you can contact me in that email address with the spool of your choice. So try to send me the material you want, the color, and the diameter, and your contact information. If you have your phone number, it's a little bit easier so that the carrier can contact you if there is any issue, and the shipping address. You just send me that, and then I will send you that spool. So yeah, and again, if you guys have some interesting topic for the next stream, just let me know. Whatever thing about 3D printing, I'm always happy to talk about this. And more question. You guys need to challenge more anything that is said in the 3D printing, and then we are going to review it together. Is PETG better than PLA? Is ABS still alive? What is PLA plus? What is a tough material, a strong material? What do I need to do in order to print safely during the night? Well, any question. So congratulations again to Abdullah for the free spool. And again, if we continue being a little bit more, then maybe I will give away a little bit more spools at the end of the live stream. So thank you guys for staying for a whole hour with me talking about 3D printing. And I hope to see you all next week to talk more about 3D printing. Thank you.